Okay, so the first problem that I have here, it says the sides of a building have lengths of 9 feet and 3 feet. So obviously this is not the most realistic scenario in the world. It says a
Okay.
wire is stretched between the two opposite corners. What would the length of the wire need to be to ensure that the walls are a 90-degree angle? So let me draw the picture for you. You got walls with 9 feet and 3 feet. So there's 9 feet, there's 3 feet. Okay? The wire is stretched between two opposite corners.
Put an angle like this.
Yep. Oh, by the way, you're being recorded too. So, just to let you know. So there's the wire. Okay. What would the length of the wire need to be to ensure the walls are at a 90-degree angle? So we want to know, how can we make sure that this will be a 90-degree angle? Well, the situation is, anytime you have a triangle with a 90-degree angle, it should satisfy the Pythagorean theorem. So here's the Pythagorean theorem. Okay? A squared plus b squared equals c squared. That should be true of any right triangle. So if we are creating a right triangle, a triangle with a 90-degree angle, then this side, and this side should be able to be plugged into this formula here. In this formula, A and B are the legs, and C is called the hypotenuse, and it is going to be the side that's opposite the 90-degree angle. So my hypotenuse has to be this side here. The other two sides, it doesn't matter which one's A and B, but this has to be C. So basically, I just plug in 9 squared plus 3 squared, and I have to solve this to see what number would make this true. What number would force this to be a right triangle? So 9 squared is 81. It's 9 times 9. 3 squared is 9. And then I add them together and I get c squared is going to equal 90. Okay? So then if c squared equals 90, the opposite of squaring is to square root. So I'm going to do that to both sides, and I will get c equal to something. So at this point, I'm going to use my calculator. So I'm going to hit the second button, because it's kind of hard to see, but if you look down here above the x squared button, you can see a square root symbol, and that's what I want to use. So I hit the green button so that I'll be able to use that square root symbol. So now when I push the x squared button, this is what I see on the screen. And I'm just going to type in 90 and hit enter. Now, this is the calculator trying to simplify without losing accuracy. It doesn't like to give us decimals when we're using square roots, because anytime your square root doesn't go evenly and you have to use decimals, you have to round somewhere, you lose some accuracy. But if you want the decimal, this is the button that does that for you all the time. This will always give you decimals. Like if you have fractions and you want decimals, the double arrow button is what you push, and you can see you get your decimal. If you don't want the decimal anymore, push it again, you get the exact value back. So if they want a decimal answer, maybe to the nearest tenth, so I've got 9.48, because that's greater than 5. It's 5 or greater, I should say. This is going to be bumped up to 9.5. So the final answer to this question is, if you want this triangle to be a right triangle, if you want this angle to be 90 degrees, the wire would have to be 9.5 feet across. The next problem we got here, we're going to talk about density. All right. So in general, density is an amount divided by the volume or the space that amount of whatever fills up. So if you're talking about like the density of an object, you would weigh it to get how much there was and divide by the volume. Here, we've got a situation where we're talking about a certain number of people living in a certain area. So we want to know the population per square mile. That's a density. So in fact, sometimes people will talk about the population density. You can live in a small city with lots of people, and that would be a high population density. You can live in a big city with not very many people. That's low population density, or any combination. So we want to know the population per square mile, okay? The word per means we're going to be dividing at some point. So this is a very simple problem. We have 235,000 people per 500 square miles. Okay? So basically all I do, I take the amount of people divided by the space they occupy. So you can cancel those out if you want. Doesn't matter either way, because you can then go to the calculator um, and we just type in, well, I've got fraction button and then 2350, or you could have typed in the whole thing, and on the bottom we're just going to put 5, and we get 470. So 470 people per square mile. And that is it. That's our answer. The end. Okay, so we're given this shape here, and it involves 3 parallel lines. Parallel lines means that they don't cross, and I know they're parallel because these little arrow symbols across each of these lines tell me that they're parallel. There is a theorem that says when parallel lines are cut by other lines, which are called transversals, transversals, and it doesn't really matter if you know the name. So these are both transversals. They are cutting my 3 parallel lines here. When that happens, the numbers that you get should all be proportional. So in other words, I should be able to set them up in a fraction. This is a proportion. A over B equals C over D. That's a proportion. And you can solve it by cross multiplying. So you'd multiply the diagonals to solve it. I'm actually going to show an easier way to do that. So parallel lines cut by transversals form proportions. So one way to set this up would be to do 24 over x equals 36 over 12. So in other words, I went top over bottom equals top over bottom. You could have also done other patterns. You could have done side over side equals side over side, but just don't switch halfway through. Don't say top over bottom equals bottom over top. That is not true. So start a pattern and stick with it. Now, when I want to solve a proportion, the way that I'm going to do that is I multiply by the diagonals that share a pair of numbers, or I multiply that diagonal, and then divide by the number that doesn't have a partner. Okay? So multiply these numbers, divide by that number. So x would equal 24 times 12, and then divide by the 36. So we'll put that in the calculator. I'm not even going to use the fraction button. I'm just going to do 24 times 12 divided by 36, and I end up with 8. So my final answer, what's this length, is 8. It makes sense if you think about it, because if you look at the pattern, if I took 8 to get a 24, I would be tripling it. Well, if I take 12 and multiply that by 3, triple that, I get 36. So the pattern works. Triple this, you get that. Triple this, you get that. Okay, that's proportional. All right. We have a second problem that's done the same kind of way. It says you got plots of lands between 2 roads laid out the way they're shown. And it says the boundaries between the 2 roads are parallel. So that means these lines are parallel. Here, here, and here. These are parallel. You can see that because of the little arrows also. The arrows tell you parallel. That's the symbol for parallel. So we've got 40 yards here. We've got 48 here. we've got 72 here, and it says we want to know the length of plot 3 along Cheshire Road. So here's Cheshire Road, here's plot 3. We want to know this length here. Well, you know this one, and this one. Parallel lines being cut by transversals form a proportion. So I'll call this x, and I'll say 40 over x is equal to 48 over 72. Okay? I look for the diagonal that has two numbers, and I multiply, and then divide by the number that's by itself. That's a short way of doing cross multiplication. So 40 times 72 divided by 48, I get 60. So this has a length of 60. And that's all you do. Okay, so what we're doing with this next problem, we're doing a study, and we've put all the numbers in a table. We've got a table of males and females, and people who like math and people who don't like math, and they did a survey and determined in both of those groups, you know, the numbers of people of each, okay? And then you can also see the total number of people that they interviewed, okay? So the frequency just means how much something happens. So it's a number of how many times something happens. The relative frequency is how often something happens with respect to the whole. Okay, because I can tell you that 1,000 people do something, and that really doesn't tell you whether that's a lot, because you don't know how many people there were overall. If I tell you 1,000 people did something, but I talked to 1,000,000 people, then that's not very many. If I tell you 1,000 people did something, and I talked to only 1,000 people, then that's everybody. So it's not just enough to know how many people do something. You also want to know how many total people you were talking to. So that's why we use relative frequency instead of just frequency. Knowing the number of people that do things is not as important as knowing the number in relationship to the total people that there were. So the first thing, we're supposed to find the relative frequency of people who hate math. So these are all the people that like math. And overall, there were 31 people. So what you do is you take the number of people that you're looking for, in this case, people who hate math, and you divide by the total number of people, which is 31, and that's your answer. You can just write that as a decimal. So 24 divided by 31, and you get 0.77. All right, so 0.77 people like math. For the next one, or hate math. The next one, the number of people who like math, well, oh, did I do this backwards? I think I did this backwards, because I said the number of people who hate math, and I used the number from the people who like it, didn't I? So I did a boo-boo here. So this is the number of people who like math. The number of people who hate math would actually be 7 over 31. So I did that backwards. So to get that one, I'm going to divide again. 7 divided by 31, and that is 0.22. Okay? So the number of people who don't like it is actually 0.22. If I add both these up, I end up getting 0.99, which is almost equal to 1. And when you add these two things up, you should always get, if you used all the decimals, you should always get 1, okay? So we got really close to 1 because we did a little bit of rounding. So to get relative frequency, just take the number of people who do something or don't do something, divide by the total number of people. It's basically all you do. So the next problem I'm going to do here, I want to combine these two variables into one using rational exponents. So the first thing that I'm going to do is I'm going to use the idea that when I have a root, which is this, and a power, I can rewrite them as a fraction. So Let's say that this is A and this is B. This can be rewritten as y to the A over B. The way I remember this is my power and this is my root. And if you think about the roots of a tree, the roots of the tree go on the bottom of the tree, and people with power are on the top of the world. So power over root. That's a way to remember that. Okay? Power over root. That's how you can rewrite this using a rational exponent. So that's what I'm going to do for each of these. So I'm going to rewrite the first expression that I have here. My power goes on top. My root goes on the bottom. And then I do the same thing here. My power goes on the top. My root goes on the bottom. Okay, now the next step after that, I'm going to multiply the variables. And when you multiply variables, you do it by adding the exponents. So this is going to be y, and then I'm going to take 5/3 plus 4/6. Okay, and actually that can be reduced. Except I guess I don't want, no, I do want to, because that'll give me a common denominator. So I'm going to multiply these by adding the exponents. So I get 2/3 here, and then that gives me y to the 7/3. And that's how I want my final answer to be. Okay, here is get rid of grouping symbols. So I'm going to use the distributive property, just like this. Okay, on both sides. Get rid of those parentheses. So negative 4 times 7 is negative 28x. Negative 4 times 5 is negative 20. 9 times negative 2 is negative 18x. And 9 times 10 is 90. Okay? So grouping symbols are now gone. Next thing I want to do is I need to move the x's.
Is that a positive 18?
It's negative because it was 9 times negative 2.
Okay, I just didn't see
Okay.
the negative on it. Oh, there
Yeah.
it is. My bad.
All
I
right.
can see my glasses. Okay.
So
So
now
the same thing. What did you say across?
I'm multiplying across. That's called the distributive property.
Okay.
So now I'm going to move this 18 over. What's the opposite of subtract 18?
Yeah.
I'm going to add 18x to both sides. So those go away on the right, and I just have 90. And then negative 28 plus 18 is negative 10x minus 20. So now I have a two-step equation. So the opposite of subtract 20 is to add 20.
I just forget what number to do it with next. The next step when you're coming down.
Yeah,
You know,
so
where,
this
I just forget where to put.
you
add or
start
subtract.
far away and move in close. You look at what you've got, you do the opposite and do it to both sides.
Okay.
So the opposite of subtract 20 is to add 20. Okay, bring down negative 10x. And on the other side I have 110. Okay?
Uh-huh.
Then I say what's the opposite of multiply by negative
Divide.
10, divide by negative 10, and do it on both sides. And I get 110 divided by negative 10 is going to be negative 11. And you can just use your calculator or cross out the zeros and then just do 11 divided by negative 1. Okay? And that's your answer. When you have a cylinder, you look at the top of the cylinder and you need to find the area of that circle. So for this problem, I start by, here's the area, pi r squared. I start by getting the radius. In this example, the radius is 6. Okay? Because the diameter is 12. So you cut the diameter in half, you get the radius. Radius is 6. It's half the diameter.
Right, that's what I thought.
Sometimes they'll give you the radius. If they don't give you the radius, you have to find it. Okay?
Okay. That much I know.
So the
That
area
much
is pi r squared. If you want the volume, you have to also multiply by the height. So volume would be pi r squared h. And basically all we're going to do is plug in numbers. So volume is pi, and they said use 3.14. r squared, and then h is 14.4. And then all we're going to do is plug this into our calculator. Okay? So 3.14 times 6 squared times 14.4. And that's my answer. So I'll write that down. 1627.8 if you want to round to the nearest tenth, which is what they told you to do. So use the diameter to find the radius if they don't just give you the radius, and then use 3.14 for pi, plug in the radius, plug in the height, and then you just saw me put them all in the calculator and get your answer. And this formula will be given to you also. Alright? The end. So the next problem says we've got a circle with a radius of 2 feet, and it says find the arc length subtended by a central angle. So let me show you what this means, because the words probably don't make a lot of sense initially. So here's a circle, and here is what's called a central angle. It's 20 degrees, okay? If you go all the way around the circle would be 360 degrees. So we're looking at part of the circle, and we want to know about this arc length. We want to know how long is this piece right here. So what you have to remember, if you want the whole circle, the circumference, the distance around, is 2 pi r. In our example, r is 2 feet. So this is 2 feet long here. So the whole circle would have a circumference of 2 times pi times r, which is 2, or 4 pi. 2 times 2 is 4 pi. That's the whole circle. Now we don't have the whole circle, we have part of the circle. If you go all the way around the circle, you get 2 pi r, which is 4 pi. What part of the circle do we have? Well, out of 360 degrees, we have 20 of the 360 degrees that we need for a full circle. So we take this fraction of the circle and we multiply by 4 pi and get an answer. So you could reduce this if you want, do it that way, like divide both those by 10, and then 4 and 36. You could divide both of those by 4 and get 1 and 9. So 2 times pi over 9. Or the other way to do it, if you don't like fractions, use the calculator. So fraction button, 20 over 360 times 4 pi, enter, still get 2 pi over 9. Okay, so the next problem says what value of x causes the function to be undefined? Basically, the word undefined is bad. It means you can't do it. So as I look at these functions that I've been given, there's one thing that's bad about these, what I would call fractions. The one thing that you always want to avoid with fractions is you don't want zeros in the denominator. Okay, no zeros in the denominator. So as I look at this function and I think about all the things that I could plug in for x, the one thing I don't want to plug in is something that would make the bottom 0. So what would be bad to plug in for x? What would cause the bottom to be 0? Well, basically, 6 would be bad, because if you look at f of 6, 6 minus 7 over 6 minus 6, on the top I get negative 1, on the bottom 6 minus 6 is 0. You should never divide by 0, so this function is undefined when x equals 6, so that's bad. So I put a line through that, say x should not equal 6, okay? And that's basically all you do. So the next problem says we're going to evaluate a function. Evaluate just means take the value and plug it in for x. So if I want to calculate f of 5, I will take this function and I will rewrite the whole thing, except I'm going to pull the x out and leave a space, but everything else I'm going to rewrite. Now, where I pulled the x out and left a space, what am I going to put in that space? I'm going to put 5, okay? And then I'm just going to simplify as much as possible. So I can write that over 1, because I've got a fraction here and I want to multiply. 5 times 5 is 25, plus 8 over, or 25 over 8, plus 3. And then if you want to, you can write this over 1. And then the next thing I'm going to do is find a common denominator. So the common denominator would be 8. So multiply top and bottom by 8. And I get 24 over 8. Now that I have a common denominator, keep it, add the numerators, and this is your final answer. So f of 5 equals 49 over 8. Or, if you don't like fractions, then just take your original problem. So I'm just going to go fraction 5 eighths times, and then I'm going to plug in 5 because x was supposed to be 5, and then I'm going to do plus 3, and I'm going to hit enter, and I get the same thing either way. So when you have a list of points like this and you want to know if you have a function, an easy way to tell if you have a function is you look at the domain. The first set of each number or each point is the domain. So these are elements of the domain. Whoops. And the second number is part of the range. Okay? If you see a number repeated in the domain, it is not a function. So here I have -2, -5, 0, -5. This is not a function because the -5 is repeated in the domain. One way that I remember this is duplicates in the domain are dumb. Duplicates in the domain are dumb. If you see a duplicate in the domain, it's not a function. If you don't see that, it is a function. As far as the range goes, we don't care. We look at the domain. So for the second example, right away I see a duplicate in the domain, not a function. I look at the third example. I got a -3, a 1, 0, -4. No duplicates in the domain. So yes, this is a function. Even though you see the 2 showing up several times, it's in the range. We don't care about the range. Problem 52. -3, -2, 3, 5. Again, it is a function because there are no duplicates in the domain. So just remember, if you see a duplicate in the domain, in other words, if that first number shows up more than once, then it's not a function. If each of these first numbers is unique and isn't being duplicated, it is a function, and that's all you do. Okay, so now I've been given 3 points that are part of a function, and the question that I'm being asked is, I want to know which graph correctly identifies the function that contains these 3 points. In other words, which graph has these points on it. So to figure out which is the correct graph for this function, just plot the points and see what you get. So 3, 0 means I go 3 in the x direction, 0 in the y direction. So far, this one looks like it's the correct graph. 3 in the x direction, 0 in the y direction. Okay, with the very first point, I see this is not the correct graph. Continuing, just to make sure that I've got the right graph, 4, 0 means you go 4 in the x direction, 0 in the y direction. So this is still a good graph, still could be a candidate. And then 1, 6, 1 in the x direction, 6 in the y direction. So it looks like I have correctly verified that this graph belongs with this function. And that's basically all you do. Okay, so I want to spend a minute talking about logarithms. So basically, this is what you're going to see. You're going to see the word log, and you're going to have a number down here that you call the base. You're going to have a number in the center here that I call the target. So just remember, targets are in the center. And then the other side, I'm going to call that x. So a logarithm is kind of the opposite of an exponential function. And the way I define it is I say that the logarithm is the number that I would raise a base to get a particular target. So when you see log base b of t equals x, that means you have a base of b. That means you're raising it to some number. And when you do that, you should expect a particular target. Okay? So anytime you see a logarithm like this, you want to rewrite it like this, and you should be able to solve it. So for example, if I have log base 5 of 25, and I want to know what that is, I'm going to say it equals x. To solve this logarithm, I'm going to rewrite it in exponential form. So 5 is my base. The logarithm, which is x, is the number I'm going to raise the base to. And the target I would expect when I do that is 25. So, what number would I raise 5 to get 25? The answer would be 2.
I'm sorry.
Because
5
5
times
squared
right,
is
right,
25.
Okay.
So log base 5 of 25 equals 2. Okay? Let's do another example. Let's say that I want to do log base 4 of 64, and I want to know what that equals. Again, write it in exponential form. So 4 is my base. The x over here by itself is the number I'm going to raise the base to. The target that I would expect when I do that is 64. Now, if you're not good at knowing what the powers of 4 are, you could do trial and error. So you could say, well, 4 to the first, well, that's just going to be 4. 4 squared is 4 times 4. That doesn't work. 4 cubed is 4 times 4 times 4. Oh, that gives me 64. So my answer for x should be 3 because 4 to the third equals 64. So log base 4 of 64 equals 3. We can look at the examples that we have up here. And again, just set them equal to x and put it in exponential form. So 5 is my base. This number is the thing I'm going to raise the base to. And this is the target I would expect. Okay? And if you don't know what x is, then use trial and error. So 5 to the 1 is 5. That's not going to work. 5 squared is 25. That doesn't work. 5 cubed, 5 times 5 times 5 is 125. That doesn't work. 5 to the fourth, 5 times 5 times 5 times 5. If you check that with a calculator, I think you're going to find that gives you 625. So that means the answer is x equal 4, because 5 times 5 times 5 times 5 is 625. So that's basically all you do. Write it in exponential form.